Although now my projector is.
Yeah, we have to warm that back up.
Okay.
Just fire it back up.
Okay. My name is Sam Harmon. This presentation is called Your Circuits, Let Me Help You Bend Them. Whatever that means. I'll move right on. Whoop. Too far. Okay. I'm going to be talking about various things related to electronic music, building your own instruments, hacking instruments, doing weird things. There's some titles I decided weren't good enough. A little bit of that. Okay, now we're going to talk first about circuit bending. It was actually originally developed in sometime in the 1960s when this guy, Reed Ghazala, decided he would have some fun with, I think it might have been an organ or something like that. Cracked it open, rearranged some things, set connections between the rearranged things, like a switch or a push button or something, to activate it, and became circuit bending. It's I like to think of it as compared to the so-called prepared piano of the early 20th century, John Cage, Henry Cowell, people like that, who would take a piano and put little objects in the strings or on the hammers so that when you played the piano, it would sound different. So yeah, if you wanted to actually circuit bend something, the easy way to do it, well, sort of easy, is take your device, crack it open, unscrew the screws, then you poke around with some test leads or something, and you stick a lead here and here, try playing it, see if it does something interesting. If it does, mark it down or keep that lead there and try setting up another one. Then when you find all the bends that you want to do and want to keep, you hook those up to, say, switches or push buttons, close it up, and you've got your circuit bend instrument. The most well-known is Reed Ghazala's Incantor, which is based off of a Speak and Spell. I don't have one of those, but I do have a sound sample. Okay, so yeah, what happened there is, the Speak and Spell was kind of rewired so that, instead of, playing word zap or whatever, it's just spitting out random phonemes. Okay. Now, I've got some examples of some things I've done. First one I will demonstrate is this Optimum. I don't know if it quite qualifies as circuit bending or as much as sort of kit bashing something that's sort of there. It's originally a Morse code practice oscillator, which had, has a thing where you would put your Morse code key, headphone output, a tone knob, and a volume knob. Well, I looked at the tone knob and I thought, well, that's about the same size as, a 1/4-inch jack. So pulled it out, put in a 1/4-inch jack, and wired that to where that potentiometer, the knob, was hooked up to. then I created these, just the one so far, a little pluggable module for it. And it's just a 1/4-inch plug, and I've got two photoresistors attached to it. And then I have this kind of crude on-off switch, which is a piece of wire. Okay. What is that one? Kind of cool. Okay. Then the next one, I actually did this yesterday. This is a, cheapo Casio PT10 keyboard, perhaps most well known for cracked it open, found a pretty good bend in between probably the primary IC on the board and a sort of random resistor, and hooked it up to a momentary switch so that that's kind of circuit bending in a nutshell, I suppose. Tomorrow there will probably be a much more in-depth talk. You should go see that. Now there are other things. I like to build a lot of musical instruments from kits. It's a place where you can kind of get your start. Because you kind of got to start somewhere. You don't want to build a modular on your, design your own modular right on the first go. That's kind of challenging. So start with something small, get your soldering skills up, whatnot. And then it can go from something that's really, really simple, that doesn't require any soldering, or you can maybe just snap things into a breadboard or something, to, wow, that's really hard because it's got a lot of surface mount parts, and it'll drive you insane trying to solder it. And, the price ranges from really, really cheap to as much as you want. And there's all kinds of things you could build. Got a couple of them here. And they often offer in the manuals for putting them together. If you want it to sound a little bit different, you can do this thing or that thing. Okay. Next thing. This I don't actually have a built example of, but NOTACON was actually donated a couple of boxes of these. It's what's called a 2-transistor ribbon controller, and you can actually mail order them for like 50 cents or 3 for $1. And what it has in it are 2 transistors, a resistor, and a capacitor. Now, you need to add some things, speaker, the little cheap speaker, some kind of way of powering it, some wire, use some cables with alligator clips. And then the ribbon part, if you had some videotape lying around, you could use that, or you could just take a sheet of paper, draw your ribbon on it with a pencil, and it uses the resistance of the graphite as the ribbon itself. So yeah, we've got these, and at some point this weekend, I think we're going to try and have a little breakout session somewhere for people to try to put these together, because I've actually got enough parts for about 10 workstations for teams of people to work on these. So, what's next? Then a little more advanced kit is the Paia Theremax. It's a theremin, which is an instrument that was originally designed around 1918, 1919 or so by a Russian inventor named Leon Theremin. And the way that it works is, unlike a lot of instruments where you have to play them by touching things, you actually play it by not touching it. So it's got these 2 antennas on it, which I actually created out of lamp parts that I got at Home Depot. Because normally the volume antenna right here, it's just a loop, so it kind of looked like a lamp thing, and that kind of looked like a lamp thing. So did that, and I got this enclosure thing basically for free. So let's try it out. So there's the Theremax. Now let's say you've built some kits, you're thinking that's pretty cool, and you want to move on to the next thing. So maybe you find something that doesn't quite come in kit form, like you find a cool post on a blog where this guy says, "Oh, I built this thing and it's really cool. Here's how I did it." Or say you come up with an idea that, maybe if I throw some things together, it'll do something kind of cool. And there's a lot of different ways that you can do your circuit board construction. You could use a breadboard, although, where you just kind of plug things into the breadboard and then, connect things with, little wire traces and whatnot. That's really, really simple to do, but it's hard to take it places because the little wires will pop out. And then you have to remember where they went. You can use a generic circuit board. I'm kind of fond of this, personally. Actually, Radio Shack has this dual IC board, as they call it, which can accommodate like an IC with up to 20 pins. And it's got necessary traces that you can kind of jumper things around. Now, however, the traces on these aren't very good, and they burn, or they come off, and it makes me angry. Probably the best way to do it, although it's kind of resource intensive and time intensive, is to actually etch your own circuit boards, where basically you get a board that has a copper, it's called copper-clad board. You basically kind of etch the traces into it by putting a mask over it with a, basically kind of a printed thing, and then you dip the board into, I believe it's ferric chloride or ferric acid, and that etches off all the stuff except for where your mask is that you printed onto it. And then what you have to do is you take the board and you have to drill all the holes for all the components. Now, this is actually a kind of well-known circuit. It was actually originally developed in 1980 by a guy named Forrest Mims III. He's kind of well-known amongst electronics. He wrote a bunch of little pamphlets that got sold at Radio Shack long, long ago. And this circuit was in one all about the 555 timer chip, and it was called the step tone generator. And it actually uses what's called a 556, which is which has two of the 555 timers built into it, and it kind of does this square wave oscillator thing. A couple of years ago, these guys known as Caustic Machines, they actually took the thing, they made a couple of little tiny changes so that instead of having a little tinny speaker hooked up to it, you can actually hook it up to a line level output. And then they decided, because it kind of sounds like something out of a video game, they're going to call it the Atari Punk Console. Last summer, I decided I wanted to build one of these, and because I'm really, really lazy and don't want to etch a board or mail out and buy one, I managed to get it to all fit on one of these little boards. So here we have it, and I'm going to look at it in a little more detail. There's the schematic. There's the board. That's what I turned it into. Now we'll... Yes, that's right here in my hand. Now mine's actually kind of special because for some reason it only works when I touch these two traces with my finger. A little bit, yeah. Okay. And then another direction you could take, instead of sort of doing discrete circuits or whatever, you could use an embedded system. And this is an approach I'm kind of fond of lately. Basically, the idea is with an embedded system, you have a kind of computer on a chip thing, where the one thing actually contains the CPU. It's got a little bit of RAM, like 16, 24K, something like that. Some storage area, and some number of bits of input and output. Sometimes even analog input that it'll sort of set itself. And there are two kind of major manufacturers in the space. One is Parallax and their PIC processor. It's probably the more well-known, more commonly used, and there's a project called MIDI Box that they build all kinds of crazy things. Sort of the MIDI Box platform uses a PIC processor, and then there are things that attach to that. They have a board that works with the SID, the Commodore 6581 sound chip, so you can actually, instead of having a Commodore 64 making the sounds, you have the SID thing just doing the sounds, and you're controlling it via MIDI or something else. And they also have a board that works with, I forget the manufacturer, Yamaha, I believe. It's a FM sound chip. And then they have other projects where you could have like a box that just has a whole bunch of knobs on it, and they control MIDI signals for other synths and things like that. And as I mentioned, then there's the other company, AVR, Atmel. Their processors are known as the AVR. It's just a kind of a different thing. And there's kind of a few projects using it, one of which is AVR Syn, which I think we'll see a little bit later. And as I mentioned, PIC is probably more popular, but AVR is kind of coming up in the world, in part due to Arduino. Arduino is a physical computing platform, as the people who designed it call it. And it's based on the AVR, the Atmel ATmega 168 currently. It was originally a slightly less powerful processor, but they beefed it up in a later revision. And this is actually a kind of scaled down version of the wiring.org environment, which also uses a similar processor, and but it's a little bit bigger, a little more powerful. Whereas this one, it's kind of small and does whatnot. The software, the Arduino environment, it's an open source thing. I think the environment is actually written in Java. There. We'll fire it up. And basically, you write your code for it in more or less C. It doesn't actually have a main. It actually has a start and a loop, but you could pretend that main says start and then while true loop. And you can, you basically write code that affects the digital and analog pins and reads them and writes to them and does stuff. Now, the other cool thing about the Arduino platform is the design of the board itself, the schematics and all that stuff is actually put under a Creative Commons license. So kind of anyone could design their own Arduino-like board. and that actually it led to a little controversy last year because people actually started calling their cloned boards Arduinos, and the Arduino people got a little messed up about it. So a number of the clone people started calling their boards Freeduinos. But an Arduino board, we'll move on to the actual guts of it, provides you 14 bits of digital I/O, so you can either define a pin as for reading or for writing. It also includes sort of an RS-232 input and output, and if you want an analog-like output, you can do pulse width modulation on those lines. It also has 6 analog inputs, which when you read from them, it returns an integer between 0 and 1023 based on what the input voltage is on that pin between 0 and 5 volts. Usually program it in C, although a guy has developed a Ruby environment for it. And as I mentioned, there are a lot of different versions. You can either buy one completely assembled, or you can buy it in a kit form and put it together yourself. The main one usually uses USB. The kit ones usually use something a little different, a kind of TTL-based serial. So you just need the one cable instead of having to have a USB. They come out a little bit cheaper with the TTL serial interface. And I'm going to talk about musical things you can do with an Arduino board. MIDI comes to mind pretty easily because MIDI is a serial protocol, runs at 31,250 bits per second, and the Arduino board can easily handle that kind of speed. So you can just write something that writes out to MIDI or reads in from MIDI and does stuff. Things that come to mind: sequencers, filter that would take something and do something with it, sync generator if you have a whole chain of MIDI devices. Something that someone has done, they basically took a piezo sensor or a buzzer, cover it in Mylar, cover that in like mouse pad material, and then hook that up to your Arduino on the analog input, and that's basically a drum pad. And so they wrote some code that reads off reads for input there, and then transmits that out to a computer or over MIDI or whatever you want to do. They call their project Ardrummo. Something I'm planning to do in the future is I have a number of drum modules that they take like just a 5-volt impulse, and then they'll play the drum sound. And I'd like to maybe set up something so that I can have MIDI control of those, so I can have them triggered from some other thing. I haven't done it yet, but it's on my agenda. Another thing that I kind of theorize that someone could do is make a MIDI to control voltage output adapter for an older analog synth, like if you have an old Moog or ARP or something like that. You could create your own digital to analog converter, and use 7 of the lines for that, 1 line for the gate that controls whether it's actually playing or not, and it would probably work relatively well. Another project that has been on my agenda for a while, and I haven't quite finished it yet, is a sort of implementation of an instrument from the late 1890s, I believe, called the clavier at lumière, which is imagine an organ keyboard, but rather than playing sounds, it displays colors. And at some point, I'm working on something that will do something like that using an RGB LED so that you can set up the colors. Now let's actually talk about projects that are done. I have here an 8-step MIDI sequencer. It transmits, it's a little hard to see, and it's kind of delicate right now, but it has 8 steps that represent 16th notes. For each note, it reads off of the analog input, whether or not, what the note value is that it's going to play. Sends a MIDI clock signal 6 times per note, because that works out to the 24 pulses per quarter note that MIDI clock uses. And generally, other than kind of the setup of the knobs and whatnot, I'm only using one kind of external part, and that's a 8-channel multiplexer. And so the Arduino is transmitting. It says, I want to look at channel 4, and then that chip sends the channel 4 input signal into the Arduino analog input. The actual code to do the work on the embedded processor, 60 lines of code, compiles down to about 3K, and in my testing yesterday, it only caught fire once. So let's give this a try. Okay. This here. I think that's the right one. Yeah. Okay, right now I've got it controlling a, it's not very happy with the data. A little Yamaha tone module, and it should be reading the MIDI data. Does not seem to be very happy with it right now, which is alarming because it worked earlier today. Oh well, this happens sometimes in the music world, the DIY world. So we'll move on to other things that you can do with an Arduino. Let's talk about actually trying to use one as some kind of synthesizer, some kind of thing that makes noise. To do like something that just kind of buzzes or makes a sound, it's not too hard. You just have to send on and off to a pin fast enough so that you kind of get the frequency that you want. You could also use the pulse width modulation, kind of do some interesting things there. And you probably have enough horsepower to kind of do some of this. Another thing you could try to do is use a number of lines as a digital to analog converter, so you could kind of get, something akin to a sampled sound, rather than kind of a buzzing kind of thing. But that's going to eat up a lot of your pins. You want something of 8-bit sort of quality. That's 8 pins. You have 14 total, so you might lose some control. Another thing you could do is actually interface to some kind of chip. Maybe something like a SID or an emulated SID, as somebody did. They actually implemented all the SID logic into a similar AVR CPU, and are using an Arduino to actually handle the control of it. I have another little theremin-like thing, pretty simple. It's actually using a photoresistor and another resistor to kind of work as similar to a potentiometer, and and then the speaker output. And we'll hook this up, just give it some power. Not not the smoothest sound in the world, but not bad for 20 lines of code.
Would it be hard to program a chromatic scale?
Probably not too hard. Yeah, it could be done. It wouldn't be too bad.
Stepping could be a really positive thing.
Yeah, it could. But like I said, I threw this together pretty quickly. So, yeah, doing it with a scale, and we'll depower that. And move on to perhaps the next thing. You could use this to play sampled digital audio. However, you have to remember that this thing has 16K of storage, 16 kilobytes, 16,000 bytes. And if you wanted to play it at, say, an 8 kilohertz sample rate, you're going to use a lot of that memory. So have fun. You could try to do something like use an external memory sort of thing. Then you have to read into it from that, and it may not be that fast. Another thing you could do is actually use it as a control mechanism, get some kind of cheapo voice recorder toy thing, and try it that way. That might work. But just because I want to try it, I threw together something that plays a sample over and over and over again, using that kind of PCM output. Make sure I got this right. Yes. And then power on the side. Yeah, so all it does is it plays a sample of int80 saying block party over and over and over again. I'd actually been considering using that for some kind of wildcard entry for block party, but it didn't happen. And so, yeah, that, roughly a little over half a second converted out to 5,286 bytes. And so my entire executable is almost 9K. So that's, starting to if you wanted it to do a lot of other things, you're going to run out of space. We could also talk about FPGAs, but I think I'm going to leave that to the discussion in the next room, in the next hour. But people have been doing some things along those lines. I just read the other day that I guess Audiker did some experiments along those lines, and kind of thought it was kind of cool. Now we'll talk a little bit about software, because sometimes you just don't have the space to do all of this kind of stuff or whatever. So you could do software DIY. And you don't even have to be a programmer. Doesn't hurt. But there are a couple of platforms out there, one for Windows, one for Mac OS X, that you can use to make your own plugins. I'm kind of fond of the one for Mac OS X because I run Mac OS X. Then there are other things out there that you could do some musical craziness with. Max MSP is pretty well known. Pure Data is something similar to Max MSP, but open source, I believe, or at least freeware. Super Collider, kind of along those lines. Now, I'll show you an example of something I threw together using Sonic Birth that I like to call the Shortwave Emulator. So, yeah, I created it with Sonic Birth. Uses a kind of low-pass filter and a sine wave modulator to kind of sound like what you're listening to is coming from a shortwave radio. I added some static to it, some kind of guy keying up Morse code over the signal, and some delay just because that made it sound nice. So let's fire up Sonic Birth. Okay, let's see if this works. Make sure that I've got the right thing plugged in. No, that's not the right thing. This one. Oh, that's not it either. There's. There we go.
Turn in at the white gate, up the red brick steps, and down the hall through those swinging doors, and over to that breadboard, better known as Katie's Kitchen. And here she is, Katie Forbes.
And it's an easy to make and most flavorful cardamom cherry
Basically, I just, you just sort of draw the audio path. So the input comes in here, things happen to it, and it goes out there, and that's more or less how it works. You can actually use this to do, either effects plugins like this. You could use it to do a synth plugin. That's a little more challenging. I've kind of experimented with it. It's tricky. So there's that. This. So now we get to the cool show and tell element of this presentation. So who all has brought awesome devices to show off to everybody? Okay, we got these two over here. Who wants to go first? Yeah, we'll see if this one works. Yeah. Yeah, let's create a little space here. Okay. How about that? Yeah, okay. So this mic works too. Cool. Yeah, there's some outlets over here, if you can reach them. There's like 3 free.
Oh, wow.
Okay, you want to explain what you got?
Sure. All right, my name is Dan Krusna. This is the Averson, and it's not my invention, but I improved a lot on the original. This was a couple of years ago, a guy that I just now realized I've never pronounced his name. So, Jarek Zimbecki, or starts with a Z, and he decided that he was going to try and create a software virtual analog synth using an 8-bit micro, which he selected the one that's actually similar to what's in the Arduino. So that one micro handles the scanning of all the inputs and actually the generation of the audio. So he couldn't really use a high-level environment, so it's all in assembly. And he actually accomplished this. And actually, some other people on the Synth DIY list which is an email list of people who make these kind of things, was asking, I wonder if I could do this. And he just came up and said, yeah, I did it. And somebody offered to make PC boards, and I bought a couple, and actually installed a slightly better part just so it had more space. And one thing is he used an older micro that didn't have a multiply, so I was able to improve a lot on the code. And so the original had, I think, just AR or ASR envelopes, and I put in ADSR, 2 envelopes, one for the filter and one for the amplifier. And what else? Oh, yeah, I added a bunch of filters. So there was the state variable filter, and then I finally got the Moog filter. low pass to fit in there, and then arpeggiator and whatever else I can think of. So I'm going to try and start it up. One thing I thought that was interesting is when I said that I would be adding features, I better plug in the audio.
Yeah.
So
It should work.
he thought that not much else could fit in there, and which I thought was strange because he was trying to do something that nobody else thought could be done, and yet telling somebody else that what they want to do can't be done. Let's see here. Let's see sound.
I'm seeing sound on the mixer.
It's not.
I think it was 3. Okay. What's going on here? So I'm getting plenty of level on the mixer.
How about now?
Like I said, it's going from the mixer into that direct box. The mixer is plugged into the direct box. I think is supposed to be channel 3 on the mixer back there. No, I think it's up there.
All right.
There we go.
Yeah, so the resonance right there was actually the Moog low pass, which was actually, it was hard to code, but somebody wrote a paper about it and had it at an audio conference. And has a nice mathematical description, and I guess a lot of the ways to make things fit into this kind of processor is mostly lots of tables. That filter took lots of inverse tangents, so you have to make a lot of compromises and say, well, I can make an 8-bit table that approximates this function, and because I got to do it 7 times, and now it takes 2 cycles, and so it's a lot quicker, but it doesn't sound as good, but it's possible, so that's what you got to do. Well, that's another thing, too. When the original kit was announced, they actually had a front panel, I don't know if everybody can see this, that they labeled all the switches just like a regular kit and had things labeled like this was the envelope, amplitude, sustain, release. The original kit only had those 3 controls. And I decided that since I was going to be adding to the software, I wouldn't label anything because I didn't know what they were going to do at the time. Plus, writing on the cases, it looks a lot better with other writing because that's where I failed pretty badly in making cases. So there's things like there's 2 oscillators, so you can transpose each one individually, but then one of the knobs has a detune for the second oscillator. There's different modes, like you enable the arpeggiator, which actually is a good idea. So there's that mode. There's a distortion, which basically XORs the 2. XORs the 2 oscillators together. You can turn off one of the envelopes, so just to get a gate, which wasn't that switch. You can sort of hear the clicking as it starts because it's instant on. And then other things like switching if the LFO controls the filter or the what else? The pitch. So I actually remap these things from time to time. I'm working on a new version and make a new board with the X Mega parts, and which will have a bunch more knobs and maybe not as many switches because I don't really need all these. So not all of them are functional right now. But I do use all of these knobs on my MIDI controller, and so that's the deficiency. I found if you don't know what you're going to do with the control, it's a lot easier to put a knob there because you're going to, at the very minimum, just have, halfway either way, count, do the same input as a switch.
Is this for LV design?
Yep. Yeah.
How much are these kits?
Oh, I don't know. I bought the board only, and it was like $10. I don't know how much the kits are.
You burn the board yourself? Or you program it yourself?
Yeah. I have a lot of other AVR projects, so I had the equipment to do that. So there's my project.
Okay, you want to come up and...
So you have an 1/8" input I can...
Yeah, we can
like
do
from
that.
your laptop?
Yeah.
Actually, I use both. I use the 4" first.
Okay. Yeah. Quarter.
Okay. Thanks. Hi, I'm Tom Robertson. First thing I'm going to show you is just a little circuit that I found on a website called musicfromouterspace.com. Yeah, he sells, he builds and sells synthesizers. He's really cool. And off in one corner of the little website is a little weird sound generator schematic. And I saw that, called my friends, hey, that's cool, let's build one. So, and this is, I built it into an old modem case, ripped out the guts, because who needs a modem anymore? So let's try it out. So this is basically just 3 square waves, and you wrench them out of a little inverter chip.
Yeah.
And an inverter circuit plus a capacitor plus a resistor equals a square wave. And if one of those is fiddleable, then you've got an adjustable square wave. And then everything else is just mashing those 3 square waves together in an interesting manner. It's got some sort of filter on the end of it. It was a neat little project, very easy to do, and fun.
Yeah. I think my next project, it's actually not, it's not going to be that one, but the Sound Lab, which is like
which is the
next
big brother.
one up. Yeah.
Now the interesting thing is that I just went back on musicfromouterspace.com, and now since I built this, he's got a whole kit and everything. So now he's got the weird sound generator, has a kit and a nice faceplate and all the buttons and knobs. And I had to build it by hand. Okay, and I want to show one more thing. And this is the
1/8 inch.
jack
Okay.
to my laptop. Move this so I can face the laptop.
Yeah. This can come out.
This is an Xbox 360 Guitar Hero controller, which has a USB connector, so it's easy to hook up to the PCs and get it to work, which I was excited to see. So I had already fiddled with making an instrument out of an Xbox 360 game controller. So it wasn't much of a stretch for me to say, wow, this Guitar Hero controller looks so incredibly cool. Now, can everybody see that? Do I need to bend it over a little bit or something? All right. So this is at heart an arpeggiator. I'm going to switch over to a nice sound and a nice pattern. Yeah, this is all C++ code on top of DirectX 8. It's got a tap tempo, so I can get it to go a little faster. So the neat thing is that you've got basically seven possible notes that you can hold down. 8 if you don't hold down any, but you've got 3 buttons for the chord. I can sharp it with one more button, and I can minor it with one more button. That's all the buttons I've got on this controller. So, I've got various switches over here that I can use to change the behavior of these buttons, but basically, playing is all about these buttons and strumming to the beat. You have to adjust its internal speed to whatever you're playing with, the band you're playing with, or the instrument you're playing with. But then after that, it's just an arpeggiator, and you just have a good time with it. And there I'm playing Duran Duran. So let me find another instrument to be a little more stringy. And you can find it on the website off of YouTube. Just GHX. Guitar Hero Experimental.
Okay, that's pretty much everything. If anybody's interested in these ribbon controller kits, got a bunch of them, so come on up.
I have something just real quick. I know we're out of time.
Okay.
I'm Peter Edwards. At risk of being a little tacky, I've been struggling with whether or not I should come up. I'm doing a presentation tomorrow with Fred Owsley. We're doing another circuit bending presentation, which I think will accompany this one very nicely, so you should all come. And I brought some stuff. I'm not going to demo it right now because I'm going to show it all tomorrow, but I do have a bunch of speak and spells, and at risk of being even more tacky, these are a sort of maxed out sequencer speak and spell mega unit. So we're going to be showing a bunch of that stuff tomorrow. But I mostly am coming up just because I love talking about this stuff, and so if people want to talk more about circuit bending, I would love to do that. And also the weird sound generator is an awesome kit, and it was so hard to keep my mouth shut while you were showing that. Music from Outer Space is just a fantastic site, and the guy keeps adding more and more material and selling more and more kits, and he's resisted it. I've been following him for years. He hasn't wanted to do it. He has another job, and the demand is so high that he keeps making more stuff. And he sells PC boards regularly, and the new Weird Sound Generator kit is a really good entry-level kit. And I built the Sound Lab as well, which is just a really awesome low-end analog synth, but high-end noisemaker for the beginner. And the filter that's on the Weird Sound Generator is a nice 9-volt low-pass filter, which is sort of rare. A lot of filters are dual polarity DC power, and they're hard to power. But his designs are great. So that's it. So yeah, tomorrow night there's going to be more circuit bending.
Yes.
And the last thing I wanted to plug, and then I'm going to go away. In New York City, the Circuit Bending Festival is coming up April 25th, and it's really exciting. It's a ton of fun. Lots of people from all over the world come and show their stuff. and it's an awesome event. Thanks.
It's on the bottom.